Okay, so in this video, we want to try to figure out how to find nth roots of a complex number. So that's the title, finding the nth roots of a complex number. Now, nth roots, we could think of it like this. Before we did problems that kind of look like this, if I said f of x equaled like x to the fourth minus 10, and I said, how many roots does this have, or how many zeros does this have? Well, you might remember from last semester that the fundamental theorem of algebra says, since the power of this thing, the degree of the polynomial is 4, it's got to have 4 complex roots. Which really means it's got 4 complex zeros. Actually, that's the term we use quite often. 4 complex zeros. Which is another way of saying there are 4 solutions to x to the fourth minus 10 equals 0, which is the same thing as saying x to the fourth equals 10. So there are really 4 different solutions to this that work. And so our goal is to figure out what 4 those are. And the way that I'm going to do it, let me take this, x to the fourth equals 10. What we want are the 4 different x's that actually work for this. Now, I'm going to phrase this slightly differently. This is really no different than if I called this thing z, and then since z is x to the fourth, these guys down here, these are really if I took the 4th roots of that thing. So this thing would be like a z to the 1/4 and another z to the 1/4 and so on. So this would be the first one, the second one, etc. So let's look at a problem here. I'm going to make up an example. Let's let z equal root 3 plus I. Okay. So when I phrase the question like this, z equals 10, then the question, instead of saying how many zeros are there, you would say how many 4th roots are there, and there are 4 of them, right? Z cubed, or z sub 3 to the 1/4 and z sub 4 to the 1/4. So now what I want to do is figure out, well, how do we get all these? So we're going to let z equal root 3 plus I, and we want to find the 4th roots of z. Okay, so that means z to the 1/4, and there should be 4 of them. Well, so the trick to this is to actually use that polar trig form of the complex number. So root 3 plus I is root 3 in the x direction and 1 in the y direction. So that means that the radius here is going to be 2, and the angle that we have here is 30 degrees. So z can also be written as 2 cis 30. Now, if I were to take the 4th root of that, z to the 1/4, that's 2 cis 30 to the 1/4, and we can use de Moivre's theorem, which says this turns into 2 to the 1/4 cis 30 times 1/4, which is 2 to the 1/4, or the 4th root of 2, whoops, not equals, cis 7.5. But that's really only one number. That's just one answer there. We're supposed to get 4 of them. So this method's not quite going to work. Instead, I want to take this number right here, 2 cis 30. That's z, but that also means that 2 cis 30 plus any increment of 360, whole number increment, right? K is an integer. That should give me the same exact number, because adding 360 still puts me in the same location in terms of cosine and sine. So now let's take the 4th root of that. Z to the 1/4 equals 2 cis 30 plus 360k all to the 1/4. And now if we use de Moivre's theorem, that turns into 2 to the 1/4 cis 30 plus 360k times 1/4. Okay, so then let's simplify that a little bit. That's 2 to the 1/4 CIS, 30 times a fourth, which is 7.5, plus 360k times 1/4, which is 90k. So if we plug in different k's, we'll get different answers for z. So one of the z's to the 1/4 is going to be when k equals 0. So I'll put over, well, first let's plug it in. So it's 2 to the 1/4 CIS 7.5 plus 90 times 0. So this right here is when k equals 0. And then we get another one, z sub 2 to the 1/4. Well, that's 2 to the 1/4 CIS, and then instead of plugging in k equals 0, we'll plug in k equals 1, and we'll get 97.5. So there's another answer, k equals 1. Then we've got z sub 3 to the 1/4, so we're going to add another 90 to that angle. So that's going to be CIS 187.5. That's when k equals 2. And we'll keep going with this. So we'll plug in another one. Z sub 4 to the 1/4 equals 2 to the 1/4 CIS. And then this is going to turn into 277.5. That's when k equals 3. Well, if we kept going, we're supposed to get 4 different answers because it's fourth roots. But if we tried a fifth one, 2 to the 1/4 CIS. If I added another 90 in here, I get 367.5. And if you think about that, I could subtract 360 from this and I'd still be in the same location in terms of the theta for cosine and sine. So that would be 2 to the 1/4 CIS 7.5 if I simplify it a little bit. But that's the same as this answer. So really, I can ignore this answer and anything that comes after it. And here are my 4 answers, my 4 unique roots that work for z, my fourth roots that work for z. So let's try one more example because the wording is a little weird in my opinion for this. The other example is, by the way, what this means here, I could take any one of these, raise it to the 4th power, and if you do that, you will get this, that z back, right? Okay, so let's do one more example. This is find the cubic roots, which are the third roots, of unity. And of unity really just means of z equals 1. That's just a fancy way of saying z equals 1. So the problem before, we had find the fourth roots of root 3 plus I. This one is find the third roots of z equals 1. So the the method that we did before was z equals 1. We want to write that in polar form first. So in polar form, z equals 1, that's just sitting right here on the real axis. The radius is 1 and the angle is 0 degrees. So this is 1 CIS 0 right there. But really, if 0 works, then it's 1 CIS 0 plus 360k. And then we'll simplify this whole thing to just CIS 360k, where k is an integer. Okay. Well, we want the third roots. So let's take the third root. So it's CIS 360k to the 1/3. And so that's, the 1 in front would be 1 to the 1/3, but that's still 1 anyway. So I'll put the 1 here. It's 1 to the 1/3. CIS, oops, I forgot the k. 360k times 1/3, or same thing as divided by 3, which is going to be 1 CIS 120k. So the third roots of 1, of unity, one of the answers is going to be when k equals 0. So when k equals 0, we get 1 CIS 0. And if you think about that, 1 CIS 0 is really just 1. And if you think about, if I said take the cubic root of 1, the one answer you're probably going to be able to think of off the top of your head is the number 1. Let's look at the next one. K equals 1. So Z1, 1/3 here. So that's going to be 1 CIS 120 times 1 here. So that's going to be 120. So that's really cosine 120 plus I sine 120. And if we use our trig knowledge for that one, cosine 120 is negative 1/2 plus I, and sine 120 is √3/2. And then if we said, well, let's keep going, what about when k equals 2? That's z sub 1, whoops, sorry, that's a 2, and this is a 3, 1/3, equals 1 CIS, and then I plug in a 2 for the k, and I get 240. So this is going to be cos 240 plus I sine 240. Cos 240 is also negative 1/2. And sine 240 is negative √3/2. So then we can write this as negative 1/2 minus I √3/2, like that. So these are the 3 cubic roots of unity right here. The cubic roots of unity, right, of 1. And so if you took any one of these 3 and you cubed them, you would get 1 back. Okay, hope that helps.